So last time we learned that using different computers to analyze an algorithm was not a great idea because every computer has different specifications and it would not make it a generalizable analysis. So what if we built one computer somewhere in the world, just one single computer, and every time when we made a new algorithm, we send it to that computer to measure its performance. Now that would solve the generalizable problem, but it might be really hard to do that, like sending every single algorithm that we found to that single computer and, running it in different inputs. That might not be possible. But instead of making a physical computer, we can imagine a computer. That's where the RAM model comes up. Random access machine. It's an imaginary machine that we are just running it in our minds to analyze algorithms. So don't confuse this with the memory, random access memory that we have in our computer. This is a different thing. This is a model that we came up with to measure algorithms' performance or analyze the algorithm. So when using this RAM model, we have some rules, some suppositions that we're going to use to analyze the algorithm. So the first one is basic operation like plus, minus, and or these logic operations and or like arithmetic operations like plus, minus, division, multiplication. They all take 1 unit of time. Number 2 is loops. Loops take 1 unit of time because you're doing the same thing over and over again. Instead of, let's say that you're adding, but addition would take once, but if you're looping 20 times, then it would take 20 times, right? So loop will be calculated by multiplying the number of iterations with number of operations inside the loop. Number 3 is read operations. So every read operation from memory will take 1 unit of time. Using these rules, we can do algorithm analysis in a generalizable way. So in the next video, we're going to talk about in what situations we can use this, and we're going to explain it a little bit more in detail.